Hi, are you an engineer who's trying to develop a cell or a battery pack, or has a product whose performance depends on the performance of a battery pack? If your answer is yes, then you certainly have a question to answer. Can you tell me the performance of your product with respect to time? For example, let me assume that you have a product which is an electric vehicle. Can you tell me its range and performance 5 years down the line? Or let me assume that you're building an eVTOL, then can you tell me how far will it fly after 3 years? Well, predicting battery aging is not a guessing game, it's a science. And that's where GT Suite as a tool can certainly help you. Batteries don't age just by being used, they also degrade over time even while sitting idle. Therefore, while developing a cell or a battery pack, cycle aging and calendar aging both should be modeled. And while developing a system, these aging models should be included for better predictions. Now, let's see how this works in practice with a very simple example of an electric vehicle. Of course, this capability extends beyond automotive applications too. Now, what you see on the screen is a simple example of regular work routines. The first case represents a regular work week where we assume that the electric vehicle commutes Monday to Friday and rests on a weekend. The second case is a vacation week. This is the battery aging model built in GT Autoland. It includes a battery pack where you can define the battery type, cell geometry, number of cells in series and parallel, define some parameters for cathode, anode, thermal behavior, and some advanced options. This is the event manager where we have uploaded the data for normal week and vacation week. Also defined some charging strategies. Some logics are defined to switch between the routines. At the bottom, we can see a section where weather conditions are included in the model. Once you run the simulation, the major results you obtain is the cycle aging and calendar aging of your battery pack. Now let's quickly see how to use this data into a system level model. This is a generic system level model of a battery electric vehicle where you can see battery, motor, inverter, vehicle, brakes, and driver behavior. Now inside the battery model, you can see the state files that were generated from the standalone battery aging model. This will allow us to initialize the battery as an aged pack. Once you run this model, range and performance are some of the major results you will be able to observe. So, whether you are developing an electric vehicle, an eVTOL, or any product of the future, with GT Suite, you can see the future today.